Foundations of amateur radio. One of the potentially trickier aspects of putting together your shack is connecting the radio to the antenna. On the face of it, the challenge is limited to making sure that you have mating connectors on both ends. But when you actually start implementing this, you'll run into several other considerations. The very first one, as I said, is the connector. Every amateur I've ever spoken to goes through the same process. You pick a connector, typically the one that your radio comes with, then you adapt the connector on your coaxial cable to suit. Then you'll get an SWR meter, a dummy load, some testing gear, a coax switch or two, perhaps another radio or an amplifier, and along the way you'll discover that you now have a growing collection of connectors to choose from, and that's just the connectors inside the shack. After considering connectors, you'll start to contemplate the coax itself. You'll likely weigh price against signal loss, but there are other aspects to the selection of the right coax for the job. For example, how do you get the coax actually into the shack? One of the main challenges associated with solving that problem is surprisingly something that rarely affects our hobby, other than any human factors associated with the phenomenon of weather. Getting coax into a shack generally involves passing through a weatherproof barrier of some sort. In doing so, you're likely to create a place where the weather can make its way into places it's not supposed to. Water can and will travel along your coax, hopefully on the outside of it, but if you're unlucky, on the inside too, likely destroying it along the way. At first glance, you'll think that water only travels down with gravity, and in an ideal world you'd be right. But as it happens, water will happily do other things, like get blown by the wind, or condensate in temperature gradients like those found near a hole you just created in your lovely weatherproof barrier. If your shack has existing openings, they're generally the easiest to appropriate. Things like gaps in the eaves, existing vent holes between roof tiles or sheet iron, plenty of existing places where you can get from inside to outside a shack. Note that this is also the case if your shack is a trestle table tucked away in an office, like mine. Before I continue, I'm about to raise some potential safety issues, but I'm not an occupational health and safety professional, so do your own due diligence. If you do need to go into your roof space, height aside, consider it a dangerous place. Make sure that there's someone to check on you, and consider alternatives to climbing up there. Wearing a face mask and full body clothing is a very good idea. Often you'll find exposed wires, deteriorating or toxic insulation, and other nasty things. Conductivity of steel roof frames and pipes are also a hazard, so be extremely reluctant to venture there. Avoidance is preferable. Working at heights 101. Don't. That said, there may be no alternative. You can lift corrugated iron sheets by undoing the roofing screws. If you do, make absolutely sure that you don't make a string of water inlet points when you put it all back together. In lifting a sheet, you can access the roof space and run your coax. Sometimes the gap between the corrugation and the rafters is sufficient to push the coax through. But if you live in a hot climate, make sure that it doesn't touch the sheeting, since coax is likely to distort, if not outright melt, if it's in direct contact with the iron sheet while the sun is belting down on it. Consider the temperature rating of your coax. Similarly, terracotta roof tiles tend to have enough space to allow coax to enter the roof space. Be very careful, since they're often fragile and potentially irreplaceable. Look for openings like existing roof fittings, things like chimneys, vent pipes, roof ridges, etc. for simpler points of entry. If you need to make a hole in your roof and seal it, there's special rubber grommets for this purpose. You cut a little opening in the grommet, too tight for the coax, then force it through. Seal to the roof with UV-stable silicone and you're good to go. Check them every so many years, they deteriorate. Speaking of silicone, if there's an existing hole that you're using, don't just seal it up. It might be there for a reason. Windows often have vent holes or gaps that will fit some types of coax, and there's inserts you can use to open a sliding window that will accommodate coax. but consider the security of that window before you commit. There's also special flat coax for running through a window frame or under a door, but check before you buy that they're suitable for the job. Ladder line is also an option. It's much thinner, can travel longer distances, but its performance can be affected by corrugated iron and other conductors. Rarely, if ever, does the initial acquisition of coaxial cable involve details like bending radius, the smallest turn you can make with the coax without destroying its characteristics, since bending causes the insulation, the core and the shield to distort to some degree, and with it affect the RF passing through. Whichever path your coax takes, consider that you can cut it short but not long. If you really must know how long the coax is, use some string to run along the proposed path. But beware, the string has a bending radius that approaches 0. Coax does not. Most coax will specify a bending radius for fixed and repeated bending. The fixed one is for a one-time only bend, and 65 mm is typical. Thinner coax tends to have a smaller bending radius, but that might affect the signal loss or the budget, or both, so take that into account. Cutting and joining also introduces points of failure, places of moisture ingress, thick spots that cannot be pulled through existing holes, and plenty of other hidden fun and games. In other words, don't be stingy. Get it right. It might cost a few bob extra, but you'll have a happier time of it. If you need to run your coax inside a wall, the tool you're looking for is called a cavity king, not of the embalming variety, though relevant if you happen to do something foolish, like drill a hole through an existing power wire in your building. So don't start drilling holes where it suits without checking first. If you do, make sure that you drill on an angle facing upwards from the outside and find a place where the coax itself doesn't get wet on the way in. Speaking of holes, terminate the coax after you installed it, not before. You can use electrical tape to attach a rope to pull the coax along its route without damaging the coax. Before you close up the roof and pack everything away, attach the connectors to the coax and properly test it. If it fails your tests, it's easier to run it again with everything in place than it is to start from scratch. Ask me how I know. In my shack, I have a run of RG214 that goes to my VHF-UHF vertical. I also have a run of quad shield RG6 that goes to my HF antenna. If you're familiar with coax indicators, you'll know that RG6 is actually 75 ohm, not 50 ohm. Given that it's made from aluminium, not copper, it's also an absolute turd to solder. What it does have going for it is that it's absurdly cheap, since it's used in satellite dish installations across the planet. It also very handily can be terminated with F-type compression connectors, which in the 25 years I've used them, I've yet to see fail. The F-type connector can accommodate a handy B and C adapter, bringing us back into the realm of amateur radio. My coax goes under the corrugated iron of my roof, through the plasterboard of my office wall, hidden away in a cupboard, snakes under the cupboard door, along the wall to the termination coax switch that is in turn connected to my radio. More on that another time. The two coax runs are tied together to ensure that they don't coil weirdly, don't pose a trip hazard, and it's connected to various fixed points along its path. None of it is permanent, other than the hole in the plasterboard inside a cupboard behind a faceplate. So after removing the coax, a blanking plate brings everything back to invisible, if that's ever required. What happens outside is a whole different story, and what it attaches to yet another. The point is that from the place of picking the right connector, you likely discovered that routing coax is potentially a bigger challenge than you might have considered at first. There are other options. What issues affect the ingress of coax at your shack? I'm Ono, Victor Kilo 6, Foxtrot Lima Alpha Bravo.